Students, myself Archana Varude from Praveen Patel College of Diploma Engineering and Technology. In today's video, we are going to study about what is thrust, what is meant by liquid pressure, and what is the relation between pressure and height, or it is also called as pressure depth relation. First we see what is liquid pressure. Here see this diagram. In this diagram it is observed that here liquid is taken in a bottle and here that liquid exerts some pressure on the walls of container. As we know that when liquid is taken in vessel, then it exerts some pressure on the walls and it is also exerts pressure on the base of vessel. And as we know that any liquid has not any fixed shape. It takes the shape of that container in which it is taken. And when we consider any liquid in a vessel, then it exerts some pressure on the walls and also on the base of vessel. And therefore from that thrust, that is also known as force, and it is defined as the total force exerted by a liquid on surface is called as thrust of liquid, and the SI unit of thrust is Newton and it is denoted by capital N. When we consider solid, then that is called as force, but when we consider liquid, then that force is called as a thrust. Then what is by pressure? As we know that when we consider definition of pressure in solids, then it states that the force per unit area is called as pressure and pressure is denoted by symbol P. And here we have to define the liquid pressure. And therefore the thrust, that means the force exerted by a liquid per unit area of the surface in contact with the liquid is called pressure, or in short it is called as a liquid pressure. Then here from definition we write the formula P equals to F upon A, where P means pressure, F means applied force and A means surface area. And here we have to write the SI unit of pressure and CGS unit of pressure. See here formula is P equals to F upon A. In numerator quantity is F, that is applied force, and in denominator quantity is area. And therefore first we write the unit of numerator, that is force as unit Newton, and for area unit is meter square, and therefore SI unit of pressure is Newton per meter square, and that unit is also known as Pascal and it is denoted by capital P small a. Then we write CGS unit of pressure. Here formula is same, that is P equals to F upon A, but here we have to write the CGS unit of force and area, and therefore CGS unit of force is dyne and CGS unit of area is centimeter square, and therefore CGS unit of pressure is dyne per centimeter square. And here 1 Newton per meter square is called as a 1 Pascal, and it is also equals to 10 dyne per centimeter square. And here these are some examples of pressure. As we know that when pressure is applied at any point, then that same amount of pressure is applied throughout the liquid, or it is applied throughout that body. And here this is the first example, that is nails with pointed tip can penetrate in the wall easily. Second example is camel can walk over desert sand very easily because of his spreaded foot. Third example is It is comparatively easy to stand on the bundle of nail than on a single nail tip. Then we see relation between pressure and height, that is also called as pressure and depth relation. As we know that while swimming we experience more pressure as we go in the downward direction, and when liquid or when fluid is taken in a vessel, then it exerts pressure on the walls and also on the base of vessel, and a liquid pressure is due to its own weight, and this liquid pressure at any point depends on the depth of liquid. See here in this diagram, here these are three nozzles, that means at some equal distance that holes are created, and when these nozzles are open, then it is observed that this water is coming from this first nozzle is nearer to the wall of that container. When we consider second height, then it is more distance as compared to first nozzle, and when we consider that third hole, then it is far away from the container. That means at this first nozzle, here this is the height, here pressure is minimum. Then when we consider second height, second hole, then pressure is maximum. But when we consider this third height, that means third hole, then at that time pressure is larger. And therefore we observe that here pressure depends on depth, or it is also depends on height. And for that here we consider any point X inside the liquid and consider the unit area around that point X. And for that, here we draw the imaginary cylinder above the point X up to the free surface of liquid. And here that area is considered as a 1, that means unit area around the point X. Here H is the height of cylinder, or it is also called as depth of point X from free surface. And here rho is the density of liquid and P is the pressure at point X, and here we have to find the pressure at that point X. And here the downward force on unit area around the point X, it is equals to weight of the liquid inside the cylinder, and that is pressure at point X, it is equals to mass of liquid in the cylinder into G, because as we know that F equals to M into G. Therefore here we write mass of liquid in the cylinder into G. Therefore P, that means pressure, is equals to volume of liquid in cylinder into density of liquid. See here this formula arises because formula for density is equals to mass upon volume, and therefore here we want to write the mass of liquid, and therefore from that formula we write mass of liquid is equals to volume of liquid into density of liquid, and therefore formula becomes P equals to volume of liquid in cylinder into density of liquid into G, that is gravity. But here as we know that when we find volume, its formula is length into breadth into height, and when we consider length into breadth, then it is equals to formula of area, and therefore here we write P, that means pressure, is equals to length into breadth. Instead of that we write area into H, that is height, into rho means density of liquid, and here G as it is. And therefore here we write P equals to, for area value is 1, H as it is, into rho into G, and therefore pressure at point X is equals to H rho G. and thus H rho G are the factors on which pressure at point in a liquid depends. And thus here from this formula we write pressure at point inside the liquid depends on depth, and as depth increases, that means as height increases, pressure also increases, and pressure at any point inside the liquid is same in all directions, and there is equal pressure at all points which are in the same level. If the level is different, then at that time pressure is not same. But if we find the pressure in same level, then at that point that pressure value is same. Here see this diagram. Here as we said that pressure at the same depth is the same everywhere in a liquid. And here we write the formula P equals to rho into G into H, where rho is density, G means gravity, and H means depth. See here, we want to find the pressure at this point, and this is the height. Okay, and for that, here the formula is P equals to rho into G into H. That's all about today's video. I hope you all understand what is by liquid pressure and what is the pressure depth relation. Thank you.